How to optimize Pandas performance. So before we get started, it's useful to remember that Pandas is written on top of NumPy, and while it gives us a very nice way to deal with tabular data, we can do SQL like things there, and it does many other interesting things like handling nans and nuns and a lot of checks there. There is a lot of overhead involved, and Pandas is slower than using, let's say, NumPy arrays. So how do we make code written in Pandas more efficient? Let's look at a few different ways. So we will consider a very simple task with some toy data. So we are generating 10,000 rows of completely random data and 4 columns. Again, like this is completely random data generated using NumPy random.random. So the task is very simple. We want to add a 1 to the first column of our data frame. So we want to add 1 to every element of the first column of our data frame. Now, how do we do this? The most naive or crude way would just be to loop over the entire data frame like this. For I in range 0 to length of the data frame, you access each data frame column and row using A and I, these indices, and you add 1 to it. And now we can actually use timeit, which is a tool, to see how much time this piece of code takes to execute. So timeit executes the code multiple times usually and tells us the average time taken to execute a piece of code and the standard deviation and so on. So we see that this piece of code takes 1.31 seconds to execute. Can we make this better? So we can use iter rows to iterate more efficiently than the naive iteration we did. For instance, now if I have redefined this function as iter rows loop, where all I'm doing again is I am iterating for index row in dataframe.iter rows. Each time I get a row, I'm taking the 8th column of the row and adding 1 to it. And if I again do timeit on this, I see that it takes 1.06 seconds, which is almost a 20% improvement by using iter rows instead of naive iteration. Okay, so what can we do better? We can use the apply method to apply something to every row of a data frame or every element of a column in the data frame. So if you see here, what we are doing here is passing a column of the data frame and doing column.apply, and we have a lambda expression here that's actually adding 1. So this is more efficient because we avoid some of the naive indexing, and if we do timeit, we see that it takes only 4.24 milliseconds instead of 1.06 seconds that we saw earlier when we actually iterated over every row. So iterating over a row is expensive, and we want to use apply instead whenever possible. That's something to remember. The next thing we can do is Pandas vectorization. So instead of even doing apply, can we directly apply an operation to a data frame column? So there are some operations that Pandas supports on its columns. For instance, if I add a scalar value to a column, it can add the scalar value to every element in the column, and this is a supported operation. Since we just want to add 1, we can actually pass the column of the data frame to this function now and just do column equals column plus 1 instead of doing apply or iterating over the rows and so on. And turns out this is much more efficient. So it takes only 558 microseconds as opposed to 4.24 milliseconds, which is almost like 8 to 10x speed up. Now, what can we do better? So finally, we can use a NumPy array. So as we know, NumPy arrays are more efficient than Pandas data frames or Pandas series. So what we can do is we can convert a column to a NumPy array. So when you call data frame A is a column of the data frame, which is a series, and when you do dot values, it gives us the underlying NumPy array. Now, when we pass this array and we do a +1 to the array in a fashion similar to what we did earlier, it's much more efficient than doing it directly on the column of the data frame. And we see that it takes only 287 microseconds as opposed to 558 microseconds, almost like, half the speed. So what did we do? So first we did basic iteration over every row, and we took the column index and we actually updated the value. That took 1.31 seconds. Then we did iter rows to iterate, and that was like 1.06 seconds, almost 20% improvement. Then we did an apply which automatically applied an operation to every row of the particular column, and that was significantly faster, which is 4.24 milliseconds. Then we did Pandas vectorization, which was 558 microseconds, and then we did NumPy vectorization, where we converted the column into a NumPy vector and then did an operation directly on the column, and that was 287 microseconds. So the source code for this or the Jupyter notebook is available on our website. You can actually follow the link in the summary to see that. And an interesting thing is that these are all very simple to do. So this is good to keep in mind whenever you write Pandas code next time. Hope this was useful. Thank you.